Hi guys, in this video we are going to talk about the prospect of mobile devices replacing conventional computers. Mobile devices are popular for obvious reasons. It's light, handy, convenient, and you can take it anywhere. And for a device that fits in a pocket, it's amazingly powerful. Besides all the functions of conventional phones, the mobile devices nowadays can also connect to the internet, take pictures, play music, and even work as a control center for IoTs. And now experts predict that the next generation of mobile device would potentially replace the conventional computers with the same, if not stronger, computation power. Before we go into details of how this can be achieved, we will first look back at how we got here. Looking back, mobile devices can almost be seen as a disruptive technology. It basically absorbed devices such as media player, digital camera, and so on. From 2011 to 2015, the percentage of population who own mobile devices doubled for smartphones and rose from only 3% to 45% for tablets. In the US, more adolescents own mobile devices than those that own computers. In 2017, for the first time worldwide, mobile devices such as tablets and smartphones are generating more website traffic than conventional computers. This marked an important milestone in the past decade for mobile device development. Such an astonishing speed of development is driven by a couple of technologies. First is the development of mobile network. Mobile network in recent years have evolved from 1G all the way to 4G, and now is progressing to 5G. The mobile broadband can reach up to 41.3 megabytes per second, with national coverage as high as 98%. Meanwhile, the number of mobile applications are soaring, reaching 3.8 million for Android and 2 million for iOS in early 2018. As a result of mobile device development, the rapidly increasing mobile applications in turn pushes forward the whole market. Many prototype products have been developed for the prospect of computer-phone convergence. For example, Razer recently released Project Linda.
What if your phone could become a computer? It's a question Motorola, Microsoft, HP, Samsung, and Huawei have all tried to answer, and now Razer's getting in on the fun. From CES 2018 in Las Vegas, I'm Mr. Mobile, and this is Project Linda, the latest laptop whose heartbeat comes from a smartphone.
As tempting as the prospect sounds, there do exist challenges that have to be overcome before reaching the age of ultimate mobile device.
The first challenge is the limited computation power for the mobile device's CPU. There are three distinct problems: the CPU architecture, the instruction set design, and the overheating problem. Also, at roughly the same size as the computer CPU, the CPU for mobile device needs to perform much complicated computational tasks. Computer CPU only needs to perform the basic arithmetical, logical, and I/O operations. By contrast, mobile devices adopt a system-on-chip architecture, which means the chip hosts CPU, GPU, sensors, LTE, and other components. Besides the computation tasks, mobile devices' instruction set also introduces complications to the challenge at hand. The Intel x86, which is the dominant computer CPU on the market, uses CISC instruction sets. CISC can execute millions of instructions, and because the computer is plugged into the socket, CPU can be at its full capacity. ARM, the typical processor for smartphones, is a different story. It adopts RISC, which is smaller and requires less energy to work. Comparing to CISC, it favors battery life more by trading off only computation. Last but not least, the heat generated by the running CPU is also the issue that needs to be solved. The major mechanism behind the modern CPU is using current to drive billions of the transistors to perform the tasks, which generates a lot of heat during the computation. The desktop can use physical methods to effectively reduce the heat, such as CPU fan or heat sink. However, the size of smartphones is much more compact than desktop. To ventilate the heat to human bearable level, it has to reduce the number of transistors, which means the trade-off between the computational power and the portability. Currently, to tackle the limitations of CPU, the most realistic solution is to improve the computation to the cloud. The recent booming of cloud computing, especially IaaS and PaaS, has made it possible for the mobile device to push the computation-intensive task to the cloud and only displays the results. Here is the impressive example about how NVIDIA company provides the cloud GPU service called NVIDIA Now to play modern games on a very cheap computer.
Ooh! Pick up your game wherever you left off with Cloud Saves. Seamlessly go from your rig to your laptop or Shield TV.
Grab a PC that you're using for work, install GeForce Now, and hopefully my boss never watches this video.
I just have to keep remembering the fact that I was playing this game through the cloud, which was impressive.
It's awesome.
The second big challenge regarding transition from conventional PCs to the mobile device of the future is the limited battery capacity. Nowadays, lithium-ion batteries are the most popular and the most widely used, but they last for quite a limited amount of time, and the phone battery is not powerful enough to power a full-scale computer without sacrificing the phone's portability. However, there is ongoing research in the area of new batteries. For example, Apollo presented the first graphene-based battery that can last 50% longer than a conventional lithium-ion battery. Future research in similar technologies is likely to produce more powerful, portable, and affordable batteries to power the mobile devices of the future.
And the final challenge of mobile devices is its smaller screen size, which results in smaller text and items are placed more compact. Phone users are also prone to eye strain due to the smaller text. To tackle these issues, some smartphones are equipped with a built-in projector that can be used to display the content into a bigger dimension without the need of external items. Some examples of these devices are the Samsung Galaxy Beam series. The Samsung Galaxy Beam could project its content to the wall. We will then be able to display the content in a larger font and possibly with the same amount of information as what would be displayed on an external monitor. This technology might be able to replace the need of having an external display in the near future. Another notable issue of the smaller screen size is the fat finger problem. Small components that are placed nearly to each other, such as the on-screen keyboard, could make the user with bigger finger misclick the intended items. One of the potential solutions can be seen from a Lenovo smartphone. From this video, we can notice that the phone is able to project an interactive display onto the table surface, allowing the user to interact with the device. Another interesting feature that could be applied is the voice interaction, where users could give any command to the devices by talking to them. These kinds of interaction could already be found in some devices such as the Google Home, Amazon Echo, and Apple HomePod. The beauty of this technology is that we don't need to bring any extra tools or learn new interaction methods, as speaking is mostly something that we all have already learned. Although these features still have many limitations on the fields and areas that could be understood by this AI, this could prove to be something that could change the way we interact with our device. In the near future, we will be able to overcome this limitation of interaction and be as productive as if we were using a conventional computers.
So overall, it seems like the current environment and the future of the technology makes it possible to produce an economically viable, efficient and powerful mobile device of the future. We're already seeing a movement towards this technology through current trends and advancements in cloud, energy and user interaction technologies, and we believe it is likely that the mobile devices of the future might replace the conventional computers. Thank you for watching.